Everyone. So today we will discuss particle in 1D box, particle in 3D box, and postulates of the quantum chemistry. So for that, first let's move on to particle in 1D box. For this, we will consider a 1D box that is divided in three regions. In the first region, your potential energy is equals to infinity, and in second region, your potential energy is equals to zero, and in third region, that is again outside the box, your potential energy is equals to infinity. We will also apply some boundary conditions, that is x is equals to 0 and x is equals to L. At these boundary conditions, your wave function will be 0. So now let's do the mathematical part now. Particle in a 1D box of length L. Now let's apply the Schrodinger's equation now. H psi is equals to E psi, and we know that H is Hamiltonian operator, which is equals to kinetic energy operator and potential energy operator, and kinetic energy operator is equals to minus h bar square upon 2m del square by del x square. Now since we are taking only 1D, that's why we have taken here del square by del x square. You can also use del square by del z square or del square by del y square, but for my convenience I have used del square by del x square. Now this is equation 1, and we will put the value of this t here, and along with this we will put all these things in equation number 1, and equation number 1 will become minus h square by 2m del square by del x square plus v psi is equals to E psi. Now what I do is I take this 2m by h square, like I'm going to make the coefficient of del square and by del x square 1. So I have to take this whole term and multiply it here and here, like I'm just multiplying this whole equation with 2m by h bar square and along with a minus sign also. Okay, so this will become del square psi by del x square minus 2m by h bar square v psi is equals to minus 2m by h square e psi. I can take this term here and take 2m by h square common, so it will become like this, e minus v psi and 2m by h square, and this del square psi by del x square will remain like this. Now let this be equation A. Now for region 1 and 3, where v is equals to infinity, let's put the value of v is equals to infinity, right? So in this equation we will put v is equals to infinity. This will become del square psi by del x square, this term, and e minus infinity psi is equals to 0. Now when we subtract or add or multiply anything with infinity, we will get infinity itself. But since this is negative of infinity, we will get negative of infinity psi. I take this here, and then I take this side down here in the denominator. 1 by psi del square psi by del x square is equals to infinity. Now this thing is only possible when your psi is equals to 0. Because anything that is divided by 0 is equals to infinity. So your psi is equals to 0 outside the box. So in region 1 and 3, your psi is equals to 0. Now in region 2, v is equals to 0. Your potential energy is 0. Like in first and third region, your potential energy was equals to infinity, but in region 2, potential energy is equals to 0. So I will use the same equation that I created from the Schrodinger's equation, and this will become, I will put e is equals to 0 here, and this will become del square psi by del x square 2m e by h bar square psi is equals to 0. Now what I will do that I will put 2m e by h bar square is equals to alpha square. Now this will become del square psi by del x square plus alpha square psi is equals to 0. Okay, so now the solution of this equation is related to the differential equations in mathematics, and we will not go there. We will directly use the solution, and if there is an equation of such a case, then we will have a solution that will be equal. That will be like this: psi is equals to a sine alpha x and b cos alpha x. So the value of this psi will depend upon alpha and x. So psi is equals to a sine alpha x and b cos alpha x. Now we will apply the boundary conditions that we created, that at x equals to 0 your psi is equals to 0, and at x equals to L your psi is equals to 0. So these are the boundary conditions. We will one by one put these boundary equations in this equation. Now let's put first x equals to 0, psi equals to 0. Put psi equals to 0, put x equals to 0 here, x equals to 0. So this will become psi is equals to a sin alpha x b cos alpha x. We have put a x equals to 0, so 0 0, and psi is equals to 0. So sin 0 is 0, so a there is no meaning. So and cos 0 is equals to 1, so b is equals to 0. So this shows that if b is equals to 0, that psi only depends upon a sin alpha x and not on this term. So Now we have one situation that psi is only dependent upon a sine alpha x. Now put x equals to L and psi is equals to 0. When we put 0 is equal to a sine alpha L plus b sine alpha L, this will be formed. But we recently found out that b is equals to 0. So 0 is equals to a sine alpha L only and not equals to this. Now this thing is possible by two ways. Either a is equals to 0 or sine alpha L equals to 0. But a can't be equal to 0, because if a will also be equals to 0, देन psi इज इक्वल्स टू ज़ीरो. यहाँ पे एक भी ज़ीरो पुट कर दिया, बी भी ज़ीरो पुट कर दिया, तो psi इज इक्वल टू ज़ीरो. सो बट देर इज no particle existing, like there is no wave function, right? So a can't be zero, but actually we have considered that hypothetical particle exists inside the box, so a can't be zero, right? If a will be zero, your wave function will be zero. So a can't be 0, and sine alpha L equals to 0. Now sine alpha L equals to 0, this is actually sine only, right? And sine is 0 when it is sine n pi. Again mathematics. So alpha L is equals to n pi. I'm just equating these two terms, alpha L and n pi. The now we will find the value of alpha. Alpha is equals to n pi by L, and we assumed previously that alpha square is equals to 2 me by h bar square. Just put the value of alpha here, you will get n square pi square L square equals to 2 me by h bar square. Now we know that h bar is equals to h upon 2 pi, and on solving all this, we will get E is equals to n square h square by 8 ml square, and the corresponding wave function is psi is equals to a sine alpha L, where v is equals to 0. And now what we will do, we will again put the value of alpha here, and we will get the wave function psi is equals to a sine n pi x by L. Now we need to find the value of this a. How we can do this? We can normalize this wave function. Like we in the previous video, I told you that all the wave functions related to the particles in quantum mechanics are normalized. That is, psi square dx is equals to 1. We are just normalizing. So psi square dx is equals to 1. We will put the value of psi here, a square sine square n pi x by L dx is equals to 1. I will take the, since a square is a constant, I will take the a square out, and we know that sine square x, x is equals to 1 minus cos 2x upon 2, right? This is a mathematical identity. So this is 1 minus cos 2 n pi x by L upon 2 dx is equals to 1. Now a square by 2, I'm taking this 2 out, and 1 minus cos 2 n pi x by L dx is equals to 1. I'm just integrating this part. First I will integrate 1, that will become x, and integration of this thing is that first the constants that are before x, the reciprocal of them will come out, that is L upon 2 n pi, and anything like the integration of cos is sine, so sine 2 n pi x by L, and on putting first L here, L, एंड यहाँ पे भी एल पुट कर दिया, और ज़ीरो तो दोनों ही टर्म्स को ज़ीरो बना देगा. एंड ऑन कटिंग दिस एल फ्रॉम एल, साइन टू एन पाई इज अगेन ज़ीरो, सो ओनली द entity that is remaining is L. So a square L by 2 is equals to 1, and a square is equals to 2 by L. So a is equals to root 2 by L. Now put the value of psi, a in the psi. So psi was equals to a sine n pi x by L. So psi will become under root of 2 by L sine n pi x by L. So this is the wave function. This is the corresponding wave, energy, and your like energy difference between the two successive energy levels is, like if one of your energy level is n plus 1 and the other one is n, then it will be n plus 1 the whole square, h square by 8 ml square minus n square h square by 8 ml square. I'm taking this thing common, and I will open this up, so this will become n square plus 1 plus 2n minus n square. This will become 2n plus 1 h square by 8 ml square. Now in the case of particle in 1D, our lowest energy is not from n equals to 0, but it is from n equals to 1, and this n equals to 1 is known as 0 point energy. Now these are the psi and psi square couples. Now since psi only depends upon sine factor, right? So these are dependent upon the so these actually the plots of psi are similar to the plots of sine function. So for n equals to 1, you have no node. Now number of nodes is equals to n minus 1. Like for example, if there is n equals to 1, though 1 minus 1 is equals to 0, so there will be no nodes, right? So similarly for n equals to 2, 2 minus 1 is equals to 1, there will be one node. So this is the node, and at from the node there will be the change in the direction of amplitude. So if the wave here is ऊपर यहाँ पे नीचे होगी, एंड सिमिलरली फॉर n इज इक्वल्स टू 3 यहाँ पे टू नोड्स होंगी, एक नोड ये रही, दूसरी नोड ये रही, एंड सिमिलरली यू कैन ड्रॉ. नाउ इन केस ऑफ साई स्क्वायर, these graphs which are down the axis, they will also come upward. So it's very easy. The psi plots are similar to the sine function, and psi square plots are also similar to the psi. The only difference is that the graphs, the parts of the graph which are down the axis, like this part, they will just come above the axis. So this is how you can plot psi and psi square. Now in case of 3D cubic system, there is nothing you have to do, just same thing you have to do, like psi is equal to psi. Like for example, in 3D, psi will depend upon like x, y, and z axis, right? We calculated for psi x. Similarly, you can write for psi y and psi z, right? uh, you just have to solve this. You can only solve root 2 by l, so root 8 by l cube. And since these things are different, right, one is dependent upon x, other is dependent on y, another one is dependent upon z, so these are different things, so they remain like this. Energy again, an x square, h square by atom will be similar, right? This is common, but these things, uh, n value will be different, your lx value will be different. But in case of cubic system, if your Lx is equals to Ly is equals to Lz, then what we have, x square by 8ml square, nx square plus ny square plus nz square. So 3D cubic system is similar to the 1D system. Your equations are same, just you have to take in consideration all the three axes, that is x, y, and z. Okay. Now, for example, E211, just put the value of nx and y and z. Your nx is equals to 2, ny is equals to 1, and nz is equals to 1. And similarly, psi 211, right? Just you have to focus what is asked, and otherwise it is similar to a 1D only. So this is it. Particle in 1D is complete, and 3D also. Now let's move on to the postulates of the quantum chemistry. So first postulate states that the state of a system is described by a function psi of coordinate of the particle and the time. This function is called state function or wave function and contains all the information that can be determined about the system. So they are saying that if there is a particle somewhere in the space, its position, like all of its information is given by a particular wave function, and that wave function is called as psi. This psi is single valued, is continuous, quadratically integrable. Okay, so the psi is actually single valued. For some value of x, it will have a particular value. Okay, it is continuous and quadratic. Now, and okay, the probability of finding the, add one more line here, that the probability of finding the particle in space is given by psi square. Okay, so this is a postulate one, you have to learn this. It can be asked to simply be written in the exam or your paper. Postulate 2. To every physical observable property, there corresponds a linear Hermitian operator. To find this operator, write down the classical operator expression for the observable in terms of Cartesian coordinate of linear momentum component, and replace each component x by x bar and px by this. Okay, they are saying that for every physical observable quantity, like what happens, that in classical world we have physical quantities like energy, force, and your kinetic energy, potential energy, but these things do not apply for the quantum particles, right? These are for the classical world. Okay, so what we have to do, that we have to create some operators. Now the operator is nothing but, this is something similar to your classical quantity. It's just that it needs to be converted into that, and this conversion can be done by taking the classical property in terms of your position and your linear momentum, and when it comes in that terms, you just replace your position x by x and your px, that is linear momentum, by minus I h del by del x. I will show you one example in the next video on operators. So for now, just learn this postulate. Now, postulate 3 states that the only possible value that can result from measurement of physical observable property is our eigenvalues. Now, they are saying that your operators will give you the eigenvalues. These eigenvalues are, you know, uh, yeah, real values. The uh, like for example, h psi is equals to e psi, your Schrodinger equation. Now, there in h psi is equals to e psi, your h operator is your quantum mechanical operator, and the eigenvalue that it is giving after being operated on your psi, it will be e. This e value will be real, not imaginary. Okay, so this is another postulate that you need to learn. You just learn these postulates for now. I will create another video on operators. I will explain it there, that what how you can calculate your quantum mechanical operator from the physical quantity. What are eigenvalues? Why are they real? What is Hermitian operator? All this will be explained in the next video. Now, postulate 4. If B is a linear Hermitian operator that represents a physical observable property, then the eigenfunction Gi of B from a complete set. So again, I will explain this in the next video. We just learn it for now. Uh, in this postulate, we need to explain the orthogonality and orthonormality. So I will make another video on this. Okay. Postulate 5. If psi q2 is the normalized state function of a system at time t, then average value of physical observable v at a time t is given by. Okay. So if this is okay, write one point that your average value of the operator is also known as the expectation value. You can get a question on this topic, and it can be calculated by your expectation value is represented by this symbol, and it can be calculated by integration of psi star, your operator when applied on psi, and d tau. Your d tau can be dx, dy, and dz. I will put a question on this along with its solution in the next video. And for now, you just learn the postulates. And okay, so this is the condition here, that this psi should be normalized. If it is not normalized, it should be divided by integration of psi star and psi. Okay, so I will explain this thoroughly in the next video on operators. And last postulate is this. So this gives the time dependent Schrodinger equation. For now, it is of no use for us. We will do it or work on it in the next few chapters, I guess, or next few topics. So this is the